So coming to the second topic for today, which is the CAD cleaning and meshing using Feko. So in general, when you have a faulty CAD, that is a big barrier for successful electromagnetic simulations. Okay? And this faulty CAD leads to several problems, including inability to create a valid mesh itself, or mesh with the discontinuities, and in some cases, the this will result in a highly inhomogeneous mesh. And an improper mesh is never good for any solver. Okay? It might impact the computational cost in terms of memory and time, or in some cases affect the accuracy of the results. The main reason for faulty CAD is the difference in CAD tolerances between different tools when exchanging the models. So having some basic CAD fixing tools will come in handy in any tool, including Feko, and that is the focus of this topic. Okay. Now, coming to the CAD fixing tools in Feko, there are few options available that are grouped into repair and rebuild tools. All the options available under these repair and rebuild tools will work only on primitive parts, meaning non-parametric geometry parts. When a geometry is imported into Feko, it always comes as a primitive, meaning the history of that geometry construction won't be available, and you cannot change the individual dimensions of the inherent parts. Okay? You can only apply the scaling operation that will make the overall geometry small or big. Okay? On the contrary, the geometry natively created inside Feko, it will be fully parametric. Okay? And if the inputted CAD comes with any faults, apply these repair and rebuild operations before you make any changes to that model. Okay? And it may be necessary to apply these repair tools several times in succession to fix it completely and generate a valid mesh. Now, without any further delay, let me demonstrate these tools using some examples. But a general guideline I would recommend is when you're using some of these tools, if any tool allows a specification of a tolerance, please go with the smallest possible tolerance. Yeah. So with that, let me open CAD Feko. And I will try to open an example for the repair and rebuild tool. So this is a CAD that is imported into Feko. And if I take my cursor close to this CAD where there is a red exclamation mark, it says the part contains geometry faults. Okay? And if I select this one, and if I see in the detail section, so whenever you select any geometry part, the detail section will list all the edges, faces, and regions associated with this particular geometry part. So this is a solid geometry because we can see a region. And if I select that region, the entire part is selected. Okay? But if I expand the faces and go through the list of faces, there I can see the faulty faces. Okay? For example, if I select a particular face, right click on it and say, okay, zoom to selection. Now I can see like where that particular surface is in the overall CAD. So this is a solid, but I can see this surface that I selected is not actually present in the CAD. In fact, this CAD looks hollow. Okay, and there are a few other faces also that I can see which are hollow. That is the reason why this geometry is flagged as faulty. Okay. Now we will go to the transform tab under which we have these repair and rebuild tools, and I will click on repair part, and I will search for the faulty parts and try to fix them automatically. Okay. If I click OK, it will start performing those operations. Now we can see that the face which zoom to selection, so it's now available. So it is not missing anymore in the 3D CAD. Okay, and the other faces that seemed to be missing before, they also came back. So now it looks like a complete solid part. Okay, but looks like there are still some more geometry faults. So if I scroll down further, I see these two more parts. Okay. So if I select just these two and right click and isolate them, I can see that these are very tiny slivers within the model. Okay. So these type of tiny slivers are never good for any CAD. So when you try to mesh, including these tiny slivers, that can lead to highly inhomogeneous mesh, extremely tiny dense elements on these particular parts, so which is not good for the solver. So what we will do is we will try to get rid of them. So I will delete them. But as soon as I delete them, I can see that this particular geometry became open. So there is no region associated with it. So if I bring back the whole CAD, show all in the model, I can see the CAD, but there is no region associated with it. And if I go to the display options and enable connectivity, I can see where are the openings. Okay, so in the two spaces, two places where I deleted the surfaces, I see the openings. So what I will do is I will go to the transform tab. I will select repair and sew faces option, which will allow me to specify some tolerance in the entire model. If any two surfaces are separated by a distance less than this small tolerance, they will be merged together, they will be sewed together. Okay, so if I click OK now you can see the region came back and now this became a solid again. Okay, so in some cases, let's say you're solving a model with a solver like MLFMM, and if you have a closed PEC structure, then you can use CFIE on it rather than the default EFIE, and a CFIE will help with faster convergence. Okay, so in those cases, to ensure that it is a closed PEC volume, we need to make sure there are no gaps in the model. So that is the reason we try to close the gaps. Okay. So once I did this, if I go to the mesh tab and enable automatic meshing, it can mesh the geometry. And if I just look at the mesh view and zoom in, I can see there is a nice mesh generated on this entire CAD. Okay. So this way, by using the repair tools, we will be able to fix the geometry faults and mesh them. Okay. Let me open another model to demonstrate the rebuild tools. Okay, so here under rebuild, we have an option to fill holes in the geometry. Okay, if I look at these geometries, so there are different shapes with holes. And this fill hole operation, it can also be performed only on the primitives. Okay, so the imported CADs are always primitives. So if I select a particular edge, and to automatically select all the edges that forms the hole, what you can do is you can right click and there is a select edge loop option. So that will select the entire hole. Click on this fill hole and maybe use this corner face to face transition and click OK. And you can see how the hole is closed. Okay. So there are other options as well, right? So if I select this one and use that QC operation, and fill hole and go to the next option, smooth face-to-face transition, click OK. Now, because of that smooth transition, instead of a flat surface, it created a different type of surface to close that hole. Okay. Now, if I look at these other shapes, so let's say I select this edge, click on fill hole using the corner face-to-face transition. So it closes the hole in this fashion. But if I select the other one, and use the smooth face-to-face transition. Click OK. So now you can see how the hole is closed. Okay. So this way, using the rebuild tool, we can fill the holes in a geometry to reconstruct the entire geometry. And some other uh, tools that are useful when working with imported CAD and trying to fix it, or like exploding the geometry into its base parts and trying to fix them. So to demonstrate that, let me reopen that initial CAD that we just worked with. So this was the part, right? So rather than going through this repair operation in the beginning, so sometimes what I do is I select the entire geometry, try to explode it. So when I explode, it will explode it into these individual parts that make up the whole geometry. And we can see all these faulty surfaces. Okay. Now I can click on the repair part and search for those faulty parts and click OK. So all those faulty parts, you can see they're all repaired. Okay. No more faulty parts. Okay. So once you have these fixed parts, in FECO, it is always mandatory to make a union of all the touching or intersecting geometry parts. So you can try to select everything and make a union of them. But when you're trying to make a union of hundreds or thousands of different parts, sometimes the union operation can fail. So if I try to make a union, so you can see in this case, the union operation failed. So when this happens, the recommendation is to union in groups. Okay. So meaning instead of trying to make a union of all the geometry parts at once, so you can select a few of them, let's say select 50 of them and make a union, and then select the next 50, make a union, and maybe select the next 50 and make a union. Okay. So once you make a union of these small groups, you can make a union of unions. So I select these 3 unions and make a larger union of these. So this way you can union in parts. Eventually you can union everything to recreate the entire geometry. Okay. So this way, by using the explode option and unioning in parts, or fixing the geometry by applying the repair operations and the repair and sew phases and rebuilding, you can fix the imported CAD and try to generate a valid mesh for the solver. Yeah. And before closing, so the general remarks I would have would be, so whenever you are dealing with this faulty CAD, sometimes it might be easy to fix the CAD in the native tool where it was created. So you can get rid of these faulty parts there and re-export and bring that into FECO. And sometimes, especially the EM groups, they work with a lot of other groups, so like mechanical groups, and the CAD that is created for mechanical purposes, for like structural analysis, it may have a lot of details with all the nuts and bolts which are not necessary. So try to get rid of those details in the native CAD and before importing it to FECO. So that will also help. So reduce the time to fix those geometry parts when you bring it into FECO. Okay. So that would be the end of my session, where you can take advantage of these repair and rebuild tools. So thank you all for joining today.